Okay, so for this morning class, we'll be talking on measuring volume and capacity. So again, to recall, last week, we're able class to discuss on measuring mass as well as we also identified class what are these devices used to measure mass as well as converting units of measure for mass between metric to metric and then metric to English as well as English to metric conversion. So for this morning, we'll proceed class with measuring volume and as well as capacity. So what you will learn in this morning are stated class in our learning objectives. So firstly, we are going to compute class some of the volume for regular solids, like for example class the cylinders, cone, cube, rectangular prisms, and as well as class for pyramids. So I'll be doing class some computations on that. And then after which, we'll be discussing class how to convert units of volume to other. For example, class, for instance, we have the metric to metric conversion, metric to English, and then English to metric conversion. So we do have class table of values that we can use to convert these units of measure from one unit to the other. So I'd like the class to take a look on this Rubik's Cube. With this Rubik's Cube, how many cubic units do this Rubik's Cube contain? Or how many cubes are present in this Rubik's Cube that we have? If we're going to count all the cubes in this Rubik's Cube, how many cubes are there in all? Okay. Plus, given this Rubik's Cube, how many cubes can this Rubik's Cube hold? Or how many cubes are there inside this Rubik's Cube? If you're given a chance class to count the number of cubes inside this Rubik's Cube, how many cubes are there in all? Okay, so by counting class, by counting the number of cubes inside this Rubik's Cube, we refer to that as the volume of your Rubik's Cube. So apparently, each face class contains, okay, so we have there, okay, so we have here, so this is 1, 2, 3, so that's 3 units with each, should we say, side. And then the other side class that we have are, yes, this is still 1, 2, and 3. This is another side of our cube that we have. And then the other side class we have here is the height of a cube. But then since they have the same measure, we can represent it class as the same variable. So this is your width, length, and then we have there the height of your cube. So I mean to say, since all sides of your cube have the same measure, I mean to say we can represent it with the same variable, which is s. So later class, we'll get understand how do we compute for the volume of a cube with side s. Okay, so that is just an opening. But then again, I do hope that by now you have now gained understanding of what a volume is all about. So when we say class volume, we are referring to class to how many cubic units are present in a given object. So typically class, we can easily compute the volume for regular solids by counting the number of cubes it can hold. But then for those objects class which are irregular in nature, if they are irregular shapes, if they are irregularly shaped solids class, what we can do is we can use class the method as we have known class from your science class, your water displacement method. So, but then again, we're not doing that water displacement method here because we are going to quantify the number of cubes that the number of cubic units that an object can contain for a regular shape objects. Again, take note class that we are just going to deal here with regular regular solids, like for example, prisms, cube, then cylinder. We can also compute as well as class cones and pyramids. So again, later we'll be discussing class how we can get the volume for a cube. So again, so when we say class volume, it is identified as the quantity measured for a three-dimensional object. So in short class, we are just going to identify how many cubic units can this object holds. So that's what we call your volume. So it is a quantity obtained from a three-dimensional object. So that is what we call class your volume. So again, as I have mentioned earlier, it's the number of cubic units that an object can contain. So specifically for regular solids. So the general formula class to compute for the volume of regular solids is we have here this formula, the following. Area of the base times the height of a given object. So again, we still apply class concept of area times the base or times the height of an object. So take note class that when you say area, it is just the measure for a two-dimensional object. So once we add class another dimension for an object and then quantify this object, we now refer that one as volume. So it now involves class three-dimensional object. So hence, from the area of the base of an object, we are going to multiply its height. So that will give us a three-dimensional quantity for a given object. So again, that's the general formula class for a volume. The base times the height of an object or the regular solid that we have. So I have here class a table representing the formula for some of the regular solids that we have. So I want you class to be familiarized. I want you class to familiarize this formula. So I guess you are very familiar with this. When you were still class in elementary, I guess you have been discussing this one, the volume of some regular solids that we have. So let's start class with the volume of a cube. So the volume of a cube class is given by the formula, which is as cube. So I mean to say class, since a cube class, all its sides have the same measure, and then as we have known, volume is a measure or it's a quantity obtained from a three-dimensional object. I mean to say, we are just going to multiply the measure of for all the sides of this cube. So we have here the height, the width, and then we have here the height, length, and then we have here the width of your cube. So I mean to say that is S times S and then times S. So that's how we are going to compute class for the volume of a cube. So say for example class, if your cube class has a dimension of 3 units, so what will be its volume? Class, if a side of a cube class measures 3 units, what will be its volume? Anybody? Class, are you still there? If a side class of a cube measures 3 units, what will be its volume? So to illustrate, so again, the volume of a cube class is given by the formula as cube. So as what I have mentioned earlier, the side of a cube measures 3 units. So mean to say class, each side of a cube is equal to 3 units. So S here class is equal to 3. So to expand, that is just equal to 3 times 3 times 3. So mean to say 3 times 3 is 9 times 3, that is equal to 27 cubic units. So again class, we call that one as 27 cubic units. We should give it the unit of measure for volume. So let's try another example. What if class, your side of a cube measures say for example, 5 units. What will be its volume? Okay, anybody? Class, I want you to share your answers via our chat box, so I can check whether you are following or there are still things that needs to be clarified. Class, about the others? Are you solving? Okay, so that is to illustrate, class, the side measures 5 units. So that is just equal to 5 cubed. So that is 5 times 5 and then times 5. So 5 times 5 is 25 times 5. That will give us 125 cubic units. So are there questions so far, class, or clarifications about getting the volume for a cube?
None, sir.
Okay, so I hope, class, that's clear. So let's proceed, class, with the volume of rectangular prism. So when you say, class, rectangular prism, so not all the sides have the same measure. Unlike, class, with a cube, wherein all sides, class, of a cube have the same measure. So this is how your rectangular prism looks like. So we have here the height, the length, and the width of your rectangular prism. So since this is a three-dimensional object, to get its volume, we are just going to multiply, class, the length by the width and by the height of a rectangular prism. So say for example, class, the length measures 4 units, while your width measures 3.2 units, and your height measures 3 units. What will be its volume? Yes, I want you to try. The length, class, measures 4 units, while the width measures 3.2 units. And the height measures 3 units. Given that dimension, what will be the volume of this rectangular prism that we have? Okay, so we have. Okay, so wait for the others to share their answers. Okay, so again, to illustrate, that is just volume is equal to length times width times height. The length measures, class, 4 units, and then the width measures 3.2 units, and the height measures 3 units. Therefore, its volume, class, is equal to 38.4 cubic units. Okay, so we should attach the unit of measure. Pero, class, when you are going to take, class, this learning task and learning check that we have in our Visual EE, so there's no need, class, to add the unit because I already added there the unit for the answer that you should have. So just give there the numerical answer without a unit. So that is just equal, class, again, to 38.4 cubic units. Okay, are there questions so far, class, or clarifications about the volume, class, of rectangular prism?
None,
So next, class, is we have there your cylinder. Okay, so by the way, class,
sir.
again, the volume, class, of a rectangular prism is obtained by multiplying the length times the width times the height. So length times width is this area of your rectangle times the height. That will give us a three-dimensional object that will compute for us the volume. So the same is true, class, with a cylinder. The area of a base we have, which is in specific, class, a circle, is given by the formula pi r squared. And then since we are trying to compute, class, the volume, we need to multiply the area of the base by its corresponding height. So this will give us a formula of pi r squared height. So for example, class, a cylinder, class, has a radius of 2.5 centimeters, and then, class, with a height of 4 centimeter. Okay, 4 centimeters. What will be its volume? Class, I want you to try working on this example that we have. A cylinder, class, has a radius of 2.5 centimeter and has a height of 4 centimeters. Then your task to get its volume. So using the formula, use class 3.14 for the value of pi. Okay, so I want your class to work on this problem. Okay. And then finally, class, round your answer to 2 decimal places. Ang final answer, class, ang i-round off to 2 decimal places. So you have to square, class, the radius, and then from there multiply the radius by 3.14 for the value of pi, and then finally multiply it with the value of your height.
Sir, 0.4 nang nasa height, sir.
Dili, this is 4 centimeters. Okay, so
Okay, sir.
okay, so dili siya 0.4, this is 4 centimeters. Sorry kung naimurag that, pero that is 4 centimeters. Okay, so to do this, class, so we have again the formula pi r squared and then height. So we have known, class, the value of pi is approximately equal to 3.14 times the radius, class, of 2.5. We are going to square this one times the height of 4 centimeters. So upon simplifying, what answer did you get? Class, what answer did you get? Is 3.14 times 2.5 times 2.5 times 4. That will give us, class, the answer of 78.5. Okay, so it's just, class, equal to 78.5. Okay, questions so far, class, or clarifications, if there are?
Answer.
Okay, so I hope, class, that's clear. But then again, class, if sometimes if you are given, class, the diameter, class, of a cylinder, what you can do is to divide the diameter by 2, because as what we have known, radius, class, is just half of a diameter. So again, if you are given, class, a diameter, divide the value by 2 so that you can get for the radius of your cylinder. So from cylinder, class, we'll be moving on with volume of a cone. The volume of a cone, class, is given by the formula 1/3 pi r squared height. If we're going to take a look, class, at the formula for getting the volume, class, of a cylinder, they are very much alike because it contains, class, this formula, pi r squared height. So take a look. So we still have, class, this pi r squared height. But then one thing that you have to note is that we multiply this value by 1/3. So you might ask, why is that so? Anybody? Why do we have to multiply this value by 1/3? Or shall we say, class, divide the volume of a cylinder by 3? Why do we have to divide it by 3? Any idea? I want you to, class, to take a look at the relationship between a cylinder and a cone. Class, can you see another relationship of a cone and a cylinder? Class, any idea? What can you say, class, between the cone and a cylinder? Okay, I guess I hear no responses. So if we're going to take, class, on our cylinder, given the cylinder, class, we can actually create 3 cones inside a cylinder. So that is why a cone is just 1/3 class of a cylinder. So say for example class, this is our cylinder, and then from the cylinder class, we can actually create 3 cones. Okay, for example, this one is cone number 1, cone number 2, and cone number 3. So mean to say class, in a cylinder, we can form 3 cones. That is why when we are tasked class to get the volume of a cone, we just divide the volume of a cylinder by 3, or volume of a cylinder times 1/3. So I hope class you get the point why we have to multiply it by 1/3, or why do we have to divide the volume of a cylinder by 3. Class, did you get that? Okay, class, in a cylinder, we can form 3 cones. So mean to say, a cone is just 1/3 class of a cylinder. So mean to say, to get class the volume of a cone, we just have to divide by 3 for the given formula to get the volume for the cylinder. Questions, class, or clarifications? Class, other questions or clarifications with regards to the volume of a cone?
None, sir.
Now, for example, class, let's try to compute. Given the diameter class of a cone, which is equal to, say, for example, 2.4 centimeter, and it has a height class of 5 centimeter. Your task to get its volume. Okay, in class, I want you to try one. Given the diameter class of a cone, which is equal to 2.4 centimeter, and then with the height class of 5 centimeter, what will be the volume of a cone, of this cone? Take note, class, that you are given here the diameter. Okay, I want you, class, to try solving this problem. Then after which, I want you, class, to share your answers in our chat box, or you can say it orally. Okay, so I give you time, class, to try to compute on your sheet. Then round your final answer, class, to 2 decimal places, or the nearest hundreds. Okay, let's just wait, class, for the others to try solving on their own before we show the answers. Although you now have obtained the answer, so that you can try solving and check whether they have obtained the same answer as what you have obtained. So if your answer, class, is different, so it's okay. So no worries, class, whether you have different answer from the rest. So one important thing here is that you tried to compute on your own, and then after which we're going to check, and then you can follow which point, class, was your solution different from the rest, so that you can check your understanding, or you can check your progress as we go along. Okay, last 2 students to share the answers. 2 more student, class, to share their answers before we show the solution. Yes, I'm still waiting, class, for the others to share their answers. Yes, are you still there? Still waiting, class? Okay, last one. Okay, so I guess we actually have 5. Okay, so again, the volume class is given by the formula 1/3 pi r squared height divided by 3. Okay, that is pi r squared height divided by 3. So the value of pi class will agree that it will be approximately equal to 14 times the radius class times 2.4. This is in terms class of diameter. So 2.4 divided by 2, we get there the answer of 1.2 square, and then times class the height of 5 centimeter, and then divide it by 3. So upon simplifying class, we should be able to get the answer of 7.54 cubic centimeter. Okay, so there are two ways class in which you can express the unit when we say class cubic centimeter. Either you will use cm cube or cc. You are still referring class to cubic centimeter using this unit. cc class, there's no need to add cube because it is now understood to be cubic centimeter. But when we use class cm, you should add exponent of 3 to identify that it is a volume. Okay, questions class or clarifications about the volume of a cone? Okay, so if there's none, maybe we can proceed with another regular solid that we have. We have your class a sphere, given class with a formula of 4/3 or 4/3 times pi r cube. So we only need class to have the radius of your sphere to get its volume. So that is 4/3 pi r cube. So for example, class, a sphere class has a radius of 4 centimeter. What will be its volume? Again, class, for example, if you have your sphere whose radius class is equal to 4 centimeters. So what will be its volume? Okay, so I want you class to try answering this problem. And then after which class, I want you class to share your answers. Class, I'm still waiting class for the others to share your answers. Okay, so don't worry class if you have different answers, so it's okay for as long as you try to solve it on your own. Okay, well anyway, we are going to show you later the solution so that you can check with your solution. Okay, so waiting class for your answers in our chat box. Okay. Yes, I'm still waiting for your answers. If you have answers there, please care to share. Okay, so we now have 4 answers. Just wait, class. Maybe last one to complete the 5. Again, class, if you have answers there, I want you to share that one to our chat box so I can see what your answers are. Okay, class, last one. Yes, are you still there? Still waiting, class, for your responses. Maybe last one will do. Okay, some more answers, class. Last one. Yes, a round off siya sa nearest hundreds ang final answer. Yes, last one. Okay, so again, so we have class. The formula for the volume class of a sphere is given by this formula. Volume is equal to 4/3 pi r cube. Okay, somehow class, this is very related class to the formula and getting class the volume of a cone. So volume of a cone is just 1/3. So inside class in a sphere, we can create 4 as cones. So that's why we need to multiply 1/3 by 4. So we get there 4/3. And then since we don't have a height class, because every measure class, every point class in your sphere, that is just equal to radius. So that is why we get there r cube. So those to substitute the formula, again, we have our 4/3 times the value of pi, which is equal to 3.14 times the radius class of 4 centimeters cube. Okay, so I hope class you have the same solution. So that is, we can have 4 times 3.14 times 64 divided by 3. So upon simplifying class, we get there the answer of 267.95. Okay, so this will be class our final answer, 267.95. So it's just again 4/3 times 3.14 times 4 cube. Okay, some more questions, class, or clarifications?
None, sir.
Okay, so I hope class you got it, the how to compute for the volume of a sphere. And then another one class is we have here the volume of a triangular prism. So in a volume class of a triangular prism, we have there the formula 1/2 times base times height, which is area of the base, times the height of your triangular prism. So again, we have there the base class is it is a triangular base. So again, we need to get the area of the base given by this formula, base times height over 2. And then we got their class times the height of your prism. So which is given by the variable capital H. So that is why we have there base times height, and then times capital H over 2. So for example, class, if your triangular base measures 4 centimeters and the height class of your triangular base measures 2 centimeter and the height of the prism class is equal to, shall we say, 2.5 centimeter, then your task class to get is volume. So what will be the volume of this triangular prism? Yes, base of a triangular, the triangular base measures 4 centimeter. Okay, so what will be the volume of this triangular prism? Class, I want you to share your answers. Given class, a triangular prism whose dimensions are 4 centimeter for the triangular base with a height of 2 centimeters, again for its triangular base, and its prism has a height of 2.5 centimeter. Then you were tasked class to get its volume. So what will be the volume for this triangular prism? Okay, I want you class to share your answers. So again, class, we can see class the formula of triangular prism, which is very related class to the formula in getting the volume for our rectangular prism. So length times width times height. So except that, we just divide it by 2 because class, in a rectangular prism, we can create 2 triangular prism inside this rectangular prism. So that is why we need to divide it by 2 to get its volume. So to give class, or to show the solution, the base class of a triangular prism measures 4 centimeters, while its height measures 2 centimeters. And then times the height of the triangular prism is equal to 2.5 centimeter, and then divided by 2. So finally, we get here class the value of 10 cubic centimeter. So this will be our final answer. Okay, questions class or clarification? 10 cc or 10 cm cube. Questions class or clarifications?
None, sir.
None, sir.
Okay, I hope class that's clear. Okay, so another one class is the volume for square-based pyramid. So square-based pyramid class means to say the base of your pyramid is a square. So this is your square pyramid, for example. So to get class, the volume of your square-based pyramid, it is just equal to 1/3 s squared times the height. So for example, class, your side of your square-based pyramid measures 2.3 centimeter. Okay, while your height class measures 1.4 centimeter. So what will be its volume? Okay, I want your class to work on this on your sheet. To get class the volume class of a square pyramid whose side of a square measures 2.3 centimeter and with a height class of 1.4 centimeter. Then after which class, I want you to share your answers via chat box, or you can say it orally. Okay. Want you class to share your answers? Okay, so I guess we have here several answers showing up. So again, to illustrate, that is just equal to 1/3 times s squared times height. So that is equal to s squared class. The side here measures 2.3 centimeter times the height class of 1.4 centimeter divided by 3. So upon simplifying class, we gather the answer of 2.47 cubic centimeter. Okay, so I hope you got it right. So this is now the final answer, 2.47 cubic centimeters. So other questions of our class or clarifications? So we also class your rectangular base pyramid. So in a rectangular base pyramid class, we to say the base is rectangular in shape. So hence we call it as rectangular pyramid. So the same thing, we just need to get class the volume of your rectangle or the rectangular pyramid, then divide it by 3. Because again, in a rectangular prism, we can form 3 rectangular pyramids. So again, length times width times height divided by 3. Okay, so for example class, the length of your rectangular pyramid measures 3.7 centimeters, while the width measures 4.2 centimeter, and then finally its height measures 5 centimeter. Then your task class to get its volume. So what will be the volume for this rectangular pyramid? So again, class, divide na siya 3 because again, in a rectangular prism, we can create 3 rectangular pyramid. So muna divide by 3. So notice that we also have the same formula, length times width times height for rectangular prism. We just divide it by 3 because again, in a rectangular prism, we can form 3 rectangular pyramids. So we have there, to substitute, it is just equal to 3.7 times 4.2 times 5, then divide it by 3. So finally, upon simplifying, we get the answer of 25.9 cubic centimeter. Okay, questions so far, class, or clarifications?
None, sir.
Okay, so another one is we have there, class, your triangular pyramid. So I guess we're done with this one. Just the same class with this pure triangular prism. So it is just triangular pyramid. So I want us to try working on this problem. So what is the volume of a rectangular prism if the base area measures 250 square centimeter with a height of 16.5 centimeter? So what will be the volume for this rectangular prism? Yes, I want you to try working on this example problem that we have. And after which, I want you to share your answers, class, in our chat box. Your rectangular prism, class, has a base area of 250 square centimeters with a height of 16.5 centimeter. So what will be its volume? So again, as what we have known, class, the general formula to get the volume is the area of the base times height. That's a general formula to get the volume for a regular solid. Find the area of the base, then multiply by its corresponding height. So in this example, the area of the base measures 250 square centimeters, and its height measures 16.5 centimeter. Then your task, class, to get its volume for this rectangular prism. So its volume should be okay. Some more answers, class. Again, the general formula, class, for the volume is just area of the base times height. So from here, we can further substitute that the area of the base measures 250 square centimeters times 16.5 centimeters. Therefore, we get here, class, the volume of this rectangular prism is equal to 4,125 cubic centimeter. So you have there 4,125 cubic centimeter. So questions, class, or clarifications? Other questions? Okay. Other questions, class? So if there's none, we can try another example.
None, sir.
Uh, Given the example problem number 2, your task, class, to find the height of a glass whose diameter measures 12.4 centimeter and has a capacity of 1,526.33 cubic centimeters of liquid. So your task, class, to get the height of this glass, which is more or less, class, cylindrical in shape. Okay, again, class, I want you to find the height of this cylindrical glass whose diameter measures 12.4 centimeter and has a capacity or volume of 1,526.33 cubic centimeters. Your task now to get its height. So I want your class to work on this example problem. So you can use in getting, class, the volume for the cylinder, which is equal to pi r squared height. So just substitute, class, the given value, and then from the given formula, you can solve in terms of height of a given object. Okay, so far, class, other questions for this example problem? Is there any questions? And then the same thing, class, round your answer to the nearest hundreds. Okay, so we have 3 answers coming up. Okay, just wait, class, for the others to share their answers. So take note, class, you are given here in terms of diameter. So you need to get first the radius of this cylindrical glass. And then from there, substitute the given value that you have and then solve for the unknown variable. Okay, we have 4 answers. Okay, maybe you can wait for last one to share their answer. So to give you a hint, so let me just try presenting some of the solution. So again, we have known class that the volume for our cylinder is given by the formula pi r squared height. And then from there, what we have known is that the volume of this cylindrical glass is equal to 1,526.33 cubic centimeters. So hence class, we substitute the variable V with this value because this is the volume of this cylindrical glass. And then substituting class the value of pi is approximately equal to 3.14. And then class, since given here is a diameter, therefore we need to divide it by 2 to get its radius. And that is why we have here 6.2. And then we need to square this one because this is its formula, r squared. So right, and then from here, h class, which is this is our missing variable. So this is our unknown variable. So we just use class letter h to represent the height of a given rectangular cylindrical glass. And then from here, we can obtain class 1,526.33 is equal to multiplying this one, we get here 120.7016H. Okay, so still class, we still have the unknown variable here, which is the height of your glass. So, and then from here, we can solve class for the value of h by dividing both sides by 120.7016, so that we can cancel out this value, and what is left here is the variable h. So that is now equal to 12.65 centimeter. So we will have to divide class 1,526.33 by 120.7016. And then finally, we'll get class this value of 12.65 centimeter. So therefore class, the height of this cylindrical glass is approximately equal to 12.65 centimeters. So other questions class or clarifications? Class, other questions? Now, by the way, class, I'd like to know if you have already discussed things like solving for a known variable in your algebra class. Okay, nag-discuss mo. So, yun sa pag-solve ang 120.7016. So, what we do, class, is just we multiply 3.14 by 6.2 and then times 6.2. So, muna nga naka-obtain ta og 120.7016. Okay, some more questions, class, or further clarifications before we proceed? Okay, wala na questions, class?
None, sir.
Okay, so I guess we're done with solving for the volume class of regular objects. So what we can do now is we'll learn, class, how do we convert units of measure for volume. So say for example, class, you were tasked to convert 3.578 liters to deciliters. So we will still be using, class, our metric ruler to convert this unit of measure. So at the centermost of our metric ruler is we have a liter, then going to your right, you have a deciliter, centiliter, and milliliter, and then going to your left, you have there your decaliter, hectoliter, and kiloliter. So what will be its equivalent value? If we have there 3.578 liters converted class to deciliters. Yes, I want you to share your answers now in the chat box. So I do hope that you are still familiar, class, with this metric converter that we have. From liters converted to deciliter. So that is going to your right. 1 unit going to your right. So that is equal to, okay, that's equal to class to 35.78 deciliters. Okay, how about this one? 3586.36 centiliters converted to hectoliters. 3,586.36 centiliters converted to hectoliters. What will be its value? That's from centiliters converted to hectoliter. So that is 1. And then our final unit class should be in terms of hectoliter. So that is going to your left. So that is 1, 2, 3, and 4. So mean to say, move your decimal point 4 places going to your left. So that should give us, class, the answer of 0.358636 hectoliters. Okay, so I hope you got it right. So questions, class, or clarifications?
None, sir.
Okay, how about this one? Suppose, class, you have a water container which measures 5 cubic yards. Then you were tasked to identify how much water can it hold in terms of cubic meters. So you are going to convert, class, from cubic yards to cubic meters. So we have here this conversion. Okay, 1 cubic yards is equal to 0.76 cubic meters. So what will be its equivalent value? Yeah, I want you, class, to try converting 5 cubic yards to cubic meters. And then if you now have, class, your answers, I want you to share it to our chat box so I can see your answers. Okay, we have 1, 2, 3. Some more answers, class, to share. 4. The last one. Okay, so we have it there. So to show you as a solution, so again, what we have known, class, is that 1 cubic yards is equal to 0.76 cubic meters. Okay, so in order for us, class, to arrive at the cubic meters unit, we need to have our cubic yards at the denominator of our fraction of our conversion factor. So that is equal to 1 yard is equal to 0.76 cubic centimeter. And then from there, we can cancel out the cubic yards unit, and what we left here is the cubic meters unit. So by multiplying, class, 5 by 0.76, we get there the value of 3.8 cubic meters. So approximately, it is equivalent, class, to 3.8 cubic meters. Okay, questions, class, or clarifications, if there are? Okay, how about this example? You bought, class, an ice cream for your alumni homecoming dinner, and you found out that its volume measures 5 gallons. So approximately, how many liters is this? Okay, gallons, class, to liters. So we have heard this conversion. 1 gallon, class, is equivalent to 3.8 liters. So what will be its equivalent if we have 5 gallons? Okay, so to show you class solution, so we have it there. 1 gallon is equivalent to 3.8 liters. Cancel out gallon. So what we have left here is your liters unit. So 5 times 3.8, we got there 19 liters. Okay, how about this one? Suppose you have a water container which can hold 6.3 liters of water. So how many quarts of water can it hold? So liters class converted to quarts. So we have it here. 1 liter is approximately equal to 1.06 quarts. Okay, I want you class to share your answers for this example. 1 liter is approximately equal to 1.06 quarts. Therefore, converted that one to quarts, 6.3 liters is approximately equal to how many quarts? Okay, so we have here the solution. That is just 6.3 liters times 1 liter is equivalent to 1.6 quarts. Okay, so that is equal to 6.68 quarts. Okay, sorry for this. I haven't rounded this one to nearest 100. So it should have been equal to 6.68 quarts so that we can have the same answer. Okay, questions so far, class, or clarifications?
None, sir.
Okay, another one. We buy a paint glass and it measures, and it has a volume, sorry, it should have been, and it has a volume of 3.5 liters. So what will be its equivalent measure in gallons? It have been its volume. Its volume measures 3.5 liters. Again, you buy a paint and its volume is 3.5 liters, and what will be its equivalent in gallons? So liters class converted to gallons, you have there 1 liter is approximately equal to 0.26 gallons. Okay, so I guess you have there 3.5 liters times 1 liters. So cancel out liters class. What is left here is your unit, which is gallon. So 3.5 times 0.26, we get there 0.91 gallons. Okay, some more questions, class, or clarifications about this lesson that we have?